Welcome to section 5.1, Operation with Polynomials. In this section, we're actually going to have multiple parts, so we're going to work towards each part slowly, step by step, because it could get very confusing if you don't understand right away or you're struggling when you're rushing. So we're going to do this step by step, pause to go back or to ask clarifying questions when you're watching through this video. Now, in the first part, we're going to cover properties of exponents. Now, for properties of exponents, we're going to actually have 8 types. Technically, it's 7, but I decided to split one of the type into 2 easier parts to understand, because in the past, many students get confused or messed up with this particular part, and I will mention it once we get to that part. Now, you're going to have this sheet of paper where you're going to write your notes. So each definition and property I'm going to cover will be added to each square, and then the corresponding example will be put into the ones next to it. So for example, the first property we're going to cover is called product of a power. So again, the first property will be product of a power. We're going to fill in the definition in here and then the corresponding example. Now, if you're not using this sheet of paper, then I would recommend that you organize your notes, put it in squares, or make a table, but make sure to have some room because I would not recommend to write big. We're going to be doing 2 types of examples for each property so that you're familiar with numbers and variables when it comes to working with exponents. Alright, so again, we're doing product of power, so it will go into this square. And then once I finish with the definition, we're going to do 2 examples. Now, for the definition of product of powers, it will be x to the a power times x to the b power, which will equal to x to the power of a plus b. Alright, now let me explain how this works. So say that you have x to the 3rd power times x to the 7th power. Now when it says x to the 3rd power, it basically means x times itself 3 times. So I'm going to write x times x times x. Now over here, it means x to the 7th power, so it's going to say x times itself 7 times. So this one was from x to the 3rd. Now we're going to write this one 7 times. So x times x times x times x times x times x times x. So this came from x to the 7th power. Now, since all these x's are multiplying, if I were to combine a shorthand version, let me count how many x's there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be actually x to the 10th power, which is the same as if I were to multiply this, found this property of exponent or law of exponent, x, so when it's x to the 3rd times same base x to the 7th, basically means x to the power of 3 plus 7, which is the same as x to the 10th power. So I wrote out the long version in order to simplify into x to the 10th power. Now, this is basically what the process is, but following this law of exponent or property is a shortcut. And here's why. If you were to work with, say, m to the 41st power times m to the 37th power, now that would take a lot of writing, a lot of time, if you were to write out the m's 41 times, and then another set of m's 37 times, just to count how many m's there are. When if you want to do the shortcut, you would just follow this property. So instead of just writing out the variables or the numbers based on the exponent, you don't want to do it when it's a lot. So we're going to follow this property, this law of exponent, as a way of doing a shortcut versus if you were to write this out. Alright, so after finish explaining about why it's beneficial using this law of exponent versus of writing it out, now let's do some examples. So we're going to start with numbers. So say we have 5 to the 4th power times 5 to the 9th power. Now they have the same base, so if it's the same base and it's multiplying, it basically means 5 to the power of 4 plus 9, which is the same as 5 to the 13th power. So this is our final answer. Now say we are working with variables. So m to the 7th power times m to the 8th power. Since it's same base multiplying, it's going to be m to the power of 7 plus 8, which is m to the 15th power, and this is our final answer. Next, we're going to be doing quotient of power, so we're going to be working in this square. So I repeat, we're going to be working in quotient of power, we're going to be working in this square. Now, quotient of power, the property definition or law of quotient of powers is x to the a power divided by x to the b power. When it's a fraction like this and it's dividing with same base, then it will equal to x to the power of a minus b. So basically mean top exponent minus bottom exponent. So you're gonna hear me asking the question, how do we work with the exponents if it's same base that are dividing? And I would expect that you would say top exponent minus bottom exponent. Now, also add in a little note where x does not equal to 0. So in the event when we're working with fraction, we have to declare that x does not equal to 0. The reason is we cannot have 0 as the denominator within a fraction, or that would be undefined. Alright, now let's do some examples. Well, before we do an example, let me show you how this one works. So say we had, I want to say w to the 8th power divided by w to the 3rd power. Now w to the 8th, meaning I'm going to write w 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Now you don't have to copy this, I'm just explaining the process, and then w to the 3rd power. So there's my w to the 3rd. Now, from here, when it's, you see how all these terms are multiplying? So, you can only do this if the terms are multiplying, never when it's adding or subtracting. So, I have the same w on the top and same w on the bottom. So this will divide into 1. And then here is another one. So if I were to divide one w from the top, I gotta do one w to the bottom, and then another one from the top, and then another one from the bottom. So you see how I divide. I didn't cancel out. I did cross them out saying that I'm dividing. If I divide 3 w's from the top, I'm dividing 3 w's from the bottom. Gotta be the same amount. Now the ones I did not cross out are the ones I have left. So 1, 2, 3, 4, 5. So basically that is w to the 5th power over 1. Since I crossed out all of them, they simply became 1, which is basically w to the 5th power. Now, that's basically following this law of exponent. W to the 8th power divided by w to the 3rd power basically means w top exponent 8 minus bottom exponent 3. 8 minus 3 is 5. So that's how it works. Now, again, it can be tedious if you were to write it out, especially when your exponents are high numbers, like w to the 70th power divided by w to the 24th power. That's a lot to write. So as long as you follow this law of exponent, this property, as a shortcut, then you're not required to write out the variables. You just follow it, and it's still going to give you the same answer if you were to use the shortcut. Now, let's do some example. So say you had 7 to the 10th power over 7th to the 6th power. Since it's the same base, my base are 7, and it's dividing, so it's going to look like 7 to the power of 10 minus 6. Top exponent minus bottom exponent. So that will become 7 to the 4th power. That's my answer for the example. Now say we were working with variables. So n to the 11th power divided by n to the 2nd power. Since it's same base, dividing is going to mean n top exponent minus, sorry, that's supposed to be 11. Top exponent minus bottom exponent equal to n to the 9th power. Now, notice how I put parentheses on the exponents when I am trying to solve or operate with them. The reason I put parentheses is to emphasize that my 10 and my 6 are exponents. Here, to emphasize that my 11 and my 2 are exponents. The reason I'm doing that is what I've seen in the past is students, when they're writing their exponents, sometimes they write it too big, so they forget that if they write it too big, that they think instead of exponents, they were just regular numbers and somehow write it in the wrong form, therefore get the wrong answer. So when you see me put in parentheses, I'm emphasizing that my 10 and my 6 are exponents, my 11 and my 2 are exponents, and I'm doing operation. In this case, I am subtracting. So here is my final answer for this example. The next property we're going to go over is negative exponent. Now this is the section, this is the property that I decided to split into two parts. And again, this is the part where many students get lost, get confused, or misunderstand. So what I did was I broke it up into two types. Negative exponents when it's on the top of the fraction. And then the second one, negative exponent when it's at the bottom of the fraction, meaning denominator. So we're going to talk about when we have a negative exponent in the numerator. And then we're going to talk about when we have a negative exponent in the denominator. So for this, we're going to be writing the properties and definition into third square right here. So again, we will be writing the property in the third square right here for the numerator, and then the one below it, we will be writing for the denominator. So first off, for the property definition, say we have x to the a power times y to the negative b power over z to the c power. When we have a negative exponent in this case, again, we need to have our final answer and positive exponents. Since we have y to the negative b power, what we're going to do is that I'm going to move my y to the opposite side. At the moment, it's on the top, so I'm going to move it to the bottom, the denominator. Everything else that has positive exponents will stay where they are, so my x to the a power will be at the top, and my z to the c power will stay at the bottom, and then my y will move to the bottom also, and then instead of negative b, it will become positive b. So, in order to change from negative exponent to positive exponent, I'm going to move my base, in this case, my y, from the top to the bottom, meaning I'm going to move it to the opposite side. Since the y is on the top, my opposite side is the bottom, so I move it to the bottom. Change my negative b to positive b. So that's all you have to do in order to convert negative exponents to positive exponents. And then I got to declare where y does not equal to 0 and z does not equal to 0. Again, we cannot have 0 in our denominator or we're going to have undefined. Now for our example, say that I had 3 to the 4th power times 5 to the negative 2nd power over 7 to the 3rd power. Now don't worry about working out the numbers. We're just going to talk about the law of exponent or the property of exponent when it's negative. So the ones with positive exponent stays where they are. So my 3 to the 4th will be continue to be at the top in the numerator. My 7 to the 3rd will stay at the denominator. My 5 to the negative 2nd power, since it's at the top, is going to move to the opposite, which is at the bottom. So I put parentheses saying that I'm multiplying. It's going to be 5 to the positive 2nd power. So see how I move from the top to the bottom and change negative to positive exponents? So that's all you have to do. Now say that we have variables. For example, m to the 8th power and then n to the negative 9th power over r to the 3rd power. So again, the ones with positive exponents stays where they are. So my m to the 8th will be in the numerator. My r to the 3rd will be in the denominator. And then my n, since it's at the top, switches to the bottom and becomes a positive 9. And I put my variables in alphabetical order. So this will be my final answer for this example. Alright, continuing working with the same property, negative exponent. Now we're going to focus when it's in the denominator. So the property is if you have x to the a in the numerator over y to the power of b, z to the power of negative c, then it will equal, meaning that the ones with positive exponents will stay the same. Will stay where they are. X to the a and y to the b power. My z had the negative c exponent, so it's going to move from the bottom to the opposite side, which is to the top. So again, we're going to move it to the opposite side for the z. So from the bottom to the top. So my z will be up in the numerator, and instead of negative c, it will be positive c. So to review, my z with the negative c power was in the denominator. I move it to the opposite side, which is into the numerator, just like right here. And I change from negative c to positive c. Let me declare that y does not equal to 0 and z does not equal to 0. Alright, let's do two examples. So say with numbers only, you have 6 to the 2nd power over 2 to the 7th power times 3 to the negative 8th power. Now the ones with positive exponents will stay where they are, so 6 squared on the top and 2 to the 7th power on the bottom. Now my 3 to the negative 8 is going to go to the opposite, so meaning from the bottom to the top. So 3 to the positive 8 power now. So again, I move from bottom to top and change negative 8 to positive 8. So here's my answer. So say we're working with exponents. So e to the 7th power over f to the negative 5th power times g to the 12th power. So again, The ones with positive exponent stays where they are, so e to the 7th, and then g to the 12th stay where they are. My f to the negative 5th is going to move to the opposite side from bottom to top, so f to the positive 5th power. So again, I move my f to the opposite side, which is to the top, change negative 5 to positive 5, and then here is my answer.